Hey guys, let's solve this problem. Delete node in a linked list. There is a single linked list head and we want to delete a node in it. You are given the node to be deleted. You will not be given access to the first node of the head. All the values of the linked list are unique and it's guaranteed that the given node is not the last node in the linked list. So delete the given node. Note that by deleting the node, we don't mean removing it from memory. We mean the value of the given node should not exist in linked list, and the number of nodes in the linked list should decrease by one, and all the values before node should be in the same order. All the values after a node should be in the same order, right? So custom testing for the input, you should provide the entire linked list head and the node to be given a node and shouldn't be the last node of the list and should be actual node in the list. We will build a linked list and pass the node by to your function. The output will be the entire list after calling your function. So so one thing we're going to do is to solve this problem. So how do we solve this problem, right? So let's say we have given a node, right? We have given a node five, right? So removing this mode from deleting this mode from a linked list is just not removing it from the memory, right? Just what we're going to do is we will swap it from the right. Let's say we are just swapping this erase its value to the one to the right. So we'll just erase its value by one, and it's gonna be um, um, the node representation for the first operation. So the next one, what we are going to do, we will change this value nine, and once we are at this position, we can just point to none, right? It's gonna be none, and the last answer is gonna be for one nine, right? So, since we are not allowing to access the head, we cannot use any linked list deletion, right? So we can just use a swapping, right? Normal swapping. So what I'm going to do is now at this to solve this problem is I'm going to use two pointers, right? I'm going to use previous and current pointer, right? So the previous pointer starts from the node to be deleted and the current pointer starts from next of it, right? And it's guaranteed that this node is not the last, the end of the linked list. It's being said, like it's being told this is not the last node or the tail of the linked list. So what we're going to do is for each operation we swap the values of the current and the previous. So it's gonna be one. Instead of swapping, just I can say the value of this previous is gonna be the value of the current, right? And I will move the previous to the current, and the current is gonna be here. And once we will move and we will swap it to nine. And once this node, once the current node is at the end, what I'm going to do is I'm going to uh, what I'm going to do is I can swap the this I can assign the value of this to the last value of this one to this, and previous points to none, right? So what I'm going to do is I'm going to say previous has to point to none, right? So once we are at this position, once current once since since this one is at since current door next is none, I'm gonna stop iterating and assign the previous value to the current, and note next is none, right? So I'm going to solve this problem in this way, and the time complexity is gonna be of n, and the space is gonna be of one operation, right? Of one, right? So I'm going to have two pointers. The previous is just the node given, and current is just node dot next, right? So while current dot next is not none, what I'm going to do is prev dot val is gonna be current dot val, right? And previous is gonna be current, and current is gonna be current dot next, right? And once we are done, what we're going to do is prev dot val is gonna be cur dot val, and prev dot next is gonna be none, right? So this is the whole operation, and the time complexity is gonna be of n in a species of one, right? So let's see if it works or not. And it's being said, for this all the constraints is just the number of nodes in is about to 10,000, and the node to be deleted is then in the list, and it's not the tail, right? So the constraints are fine, right? So let's see if it works for the given um, tests, and it's submitted and see if it works or not. So, okay, as you can see, it passed, and this is all about deleting a node. So thank you very much.